Hi everyone. For the last couple of weeks, I've been looking at how part-time workers respond to time and a half pay. When part-time workers are receiving this higher pay, do they work more or less? To begin to answer this question, let's look at the income and substitution effects. The utility max and budget constraint model on the left here shows the case for when the income effect prevails over the substitution effect. When this happens, workers who receive higher pay respond by using it to purchase more leisure. Thus, the worker works less. We see this in the corresponding downward sloping labor supply graph. On the right, we see a utility maximization and budget constraint model that shows us when the substitution effect prevails over the income effect. When this happens, workers who receive higher pay respond by finding the cost of leisure, which is actually the wage, more expensive. So they decide to work more. We see this in the corresponding upward sloping labor supply graph. To answer this question of how part-time workers respond to an increase in their pay, I surveyed 57 part-time workers at Caloriso's Farm Stand and Garden Center. The store is a unique choice to use as a case study for this question. 80% of the payroll is part-time workers. Therefore, the decisions and labor practices of these part-time workers have a strong influence on how the day-to-day business of the store is being run. The store has been family-owned and operated for the last 70 years. Therefore, there is a great sense of tradition, so it's easy to make very general assumptions that hold true throughout the survey in its corresponding analysis. The store has also been paying all of its workers time and a half pay on Sundays since 2016. That means that all survey respondents have always had the option to work on Sundays for time and a half pay. So in particular, I ask if the number of hours a part-time worker typically works in a week influences whether or not they work more or less with higher pay. I asked respondents a series of questions in this survey. So the first question I asked them helped calculate the dependent variable. So this is the question I asked all respondents, and 10 to 6 is a pretty average shift at the store. The store is Caloriso's Farm Stand and Garden Center is open from 8 to 8 every day. So the majority of shifts are about 8 hours long, and they're pretty similar to this 10 to 6 shift. Maybe they're like 9 to 5 or 11:30 to 7:30. Oh, I'm sorry, 11:30 to 7:30, but they're pretty hovered around that central tendency of 10 to 6 and 8 hours long. So to calculate the dependent variable, I took the respondent's optimal shift on a Sunday, and I calculated the number of hours that would be. Then I took this value and subtracted it from the value of the standard 10 to 6 shift length, which is 8 hours. And this became the dependent variable. So in this case, this survey respondent optimally worked 7 hours on a Sunday. Let's say assume that they work 8 hours on a Saturday. So the dependent variable for this respondent would be -1. I also asked survey respondents a series of questions to collect data on independent variables. Some of these answers were pretty straightforward and are easily identifiable in the data collection. Like the first 3 questions you see here for length of employment, number of days typically worked in a week, and number of hours worked in a week. However, I just like to note the use of the dummy variables in the next 3 questions. And I made the general practice throughout calculating the variable quant amounts, that the first choice in a question is designated as a 0, the second choice is designated as a 1. So for example, in the 4th question, I am a cashier or I am a setup boy, which is kind of like your stalker. If you're thinking of your traditional grocery store, a 0 is designated 0 means the worker is a cashier. So then taking the independent variables collected, I ran a correlation. I tested for correlation on the variables. I removed the education and days worked per week variables because they had high correlation with other variables. And those variables that is seen by the blue boxes in this matrix. While the spending and fun variables had rather high correlations, you can see this in the purple boxes, I decided to leave these categories in for these variables in my regression to minimize omitted variable bias. So using the 6 independent variables left after removing the education and days worked per week variables, I ran a regression and I tried to correct functional forms when applicable. For example, variables like length of employment and savings, but I only found making hours quadratic to improve the model. And then once I ran this regression with hours being quadratic, my variables for hours worked per week in labor category were statistically significant in the 95% confidence level. So we saw the income effect prevail for part-time employees who work 11 to 26 hours per week, and we saw the substitution effect prevail for part-time employees who work 27 to 60 hours per week. So yes, it's great that these results are statistically significant, but are they economically significant? Well, if you look at your average part-time employee who works about 22 hours a week, if they're working 22 as opposed to 21, they're going to work about 3 minutes less on a Sunday, holding all else constant. Now, a manager or whoever's creating the schedule isn't going to schedule someone for 3 minutes left, so it's not economically significant in that regard. However, if you think of it in terms of it's maybe a Sunday night and someone is scheduled 10 to 6 on a Sunday and it's 5:57 and the store isn't busy, someone who's working 11 to 26 hours per week, or in this case, this person who's working 22 hours a week might leave 3 minutes early on Sunday and not stay till 6 o'clock, as opposed to someone who's maybe working 40 hours a week. If it's 5:57 and it's not really busy, they're going to stay a few minutes. They're going to stay at least until 6 and might even probably stay and try and stay a couple minutes later, take their time leaving for the day and signing out so they can get that extra couple dollars or cents in this regard. And then when we take a look at the labor category, we see that setup boys are willing to work about 1.1 hours more than cashiers on Sundays, meaning that they respond more strongly to the substitution effect than cashiers. I found this result very interesting because setup boys do more physical labor. They're moving tables, they're moving displays, picking up plants, bringing them across the store, bringing trash out. While they're doing a lot of physical labor, they actually have a lot of downtime and they have a little bit more opportunity to socialize with each other and they have more chances to check their phone. They're not really being watched as closely by the management because they're doing more activities. In comparison, the cashiers have a more mentally taxing job, keeping a watch on customers and doing that interpersonal service and being responsible for the money. So while it's interesting to think that you would maybe think that doing more physical labor is more exhausting, we all should consider that there's different types of exhaustion. And it's very interesting just a point of notice that I talked about earlier, how the store is extremely run in tradition and has a his kind of pattern and set way of doing things. All setup boys are in fact boys, and all part-time cashiers are girls. So you could even say that boys work 1.1 hours more than girls on Sundays, but I don't think this is a gender effect. I really do think this has to do with the type of work being done. And obviously there are limitations with every survey, regression and study. So obviously working with a limited number of observations and looking at only one firm makes this a case study, and the results found in this study are applicable to Calorisas and its part-time workers. It would be interesting to expand it to more in the future. And also, I touched on this next point a little bit earlier, but the flat number of Saturday hours worked per week. And I think in the future, I would try and maybe change the question and change the way the regression is run, but I don't know if assuming everyone works 8 hours on a Saturday really is a problem because it is that central tendency shift. But it's always just a point of notice anyways. Then there was the decision to reduce and the struggle to reduce omitted variable bias versus adjusting for correlation. So making that choice of what variables to keep and what variables to eliminate obviously change the results of the regression. And there's really no clear cut, there's no clear obvious, oh, if there's this, percentage of correlation, then you should cut it. And then there's this last point of personal bias. I did my best to try and minimize this effect, as I've been a part-time employee at Cal Reso's Farm Stand and Garden Center for 4.5 years. I tried to remove my personal feelings and thoughts and influence on the survey responses and conducting the data, but just to, if there's ever something I'm not sure of, a subconscious me asking my coworkers to fill out a survey, who I must know and thank them for being so enthusiastic about wanting to help me and asking me to take the survey when they heard about it, but you can never just be too sure. So I just want to make that a point of notice. So thank you for watching, and I hope you learned something from this presentation.